All right, so if you want to look at worksheet 16 in your packet, you can. Otherwise, the things we're going to do are primarily on the worksheet I gave you. This is the formula to find the future value of an account if it's an annuity account where you're making continual payments. Let me talk about this. Okay, so Hofbauer finally started saving for retirement a few years ago, and they're taking money out of every paycheck and putting it towards my retirement. That's called an annuity. So I am making payments into an account and not taking anything out, okay? This is the formula to find the future value. Can you imagine how many sets of parentheses you'd need to put that in your calculator? Way too many, right? So we're going to use this special program that will do all this for us. The program, when I showed it to you a second ago, it said TVM. I never knew until I read this. That stands for Time Value of Money Solver. You can solve for any of those things. I just wanted to show you the other. This is how to figure out a payment if you were borrowing money for a house or a car. Likewise, crazy, right? So we're going to use this app. Now, on your little peach half sheet, it does have these things defined. It says N is number of payment periods. I is interest rate. Does everybody see that on the calculator? Here, you can just see it on this screen. But it's I%. You don't have to move the decimal over. You just put it in as a percent. So if it's 2% interest, you just put 2%. Everybody good? PV is present value. So that would be if you borrow money for a car, that's where you put that present value. If you are going to put money into a savings account, you might start with 0 there, depending how you're doing it. Payment is the amount of a payment. PMT stands for payment. FV stands for future value. Okay, if you're saving for retirement, that's the number you want to be big, right? If you're paying off a loan, what do you want a loan amount at the end to be? 0. Everybody with me? Future value of a loan, you want to be 0. All right, payments per year and compoundings per year. Since we're just doing a few of these for fun this year, we're just going to leave those at 12 and 12, okay? The P per Y and C per Y, we're going to put at 12 and 12 and leave them, which is generally what we would use anyway. We do want to make sure that this bottom setting is on end. I believe that's the default, but we want to leave it there. All right, and it says here you need to know these, but you don't because we're not going to test on this. All right. So this is on worksheet 14. It says an investor pays $600 quarterly into an annuity. I really don't want to do this question because I just said we were going to leave it 12 and 12. I'm going to skip it. All right, we're going to go down to this one. You borrow $170,000 from the bank to purchase a home. The 30-year loan has an annual interest rate of 4.5%. Calculate your monthly payment and the amount paid after 30 years. Okay. 16A, is that right or not? Is it at the bottom of 16A? Okay, thanks. This is like example 1, and then example 2 is on the sheet you have. All right. So what did I just say? This is 16A, the bottom. N is number of payments. If you borrow money for 30 years and you're making monthly payments, we can literally type in here 30 times 12 and it'll turn into a 360, or you can type 360 in, but it's kind of nice that it'll let you just type in the calculation there. Present value, we are borrowing $170,000. Now, I forgot to tell you something really important about this app. Half the time we get negative numbers. That's because it has to have a way to determine, is it you giving the bank money or the bank giving you money? Okay, so the signs are opposite. It doesn't matter which you put in as which, as long as in your head you understand that one was me giving them money and one was them giving me money. So we could say I'm gonna start $170,000 in the hole, if that makes you feel better. Putting it negative, you can put it positive, it won't matter. Okay. The future value at the end of the loan, we want this to be down to 0. We're going to leave P per Y and C per Y at 12. The payment is what we're going to try to find. So we're going to put our little cursor there, and then we're going to do second. Is it second enter? It's not second enter. Is it alpha enter? Alpha enter to get the green solve. And the interest for this one was 4.5. We do not move the decimal. All right, let me show you how this works. So you go to your calculator. Let me see if I can make this a little bigger. Let me see if I can make this a little bigger. All right, so you go to this apps button and you hit enter because we're going into the finance app. And you hit enter because we're going to use the solver, which is our best buddy. Now, the number of payments was 30 times 12, and you can hit enter and it'll turn into a 360, or you can just type a 360. Everybody good? I forgot the interest. Was it 4.5, 4.5? Okay, we're literally just going to type a 4.5, hit enter, and it'll go down. We can put this in as a negative or positive. It just means that our payment will be the opposite sign. Make sure you get enough zeros in there. Negative 170,000 is what I talked about putting in there. Now, if you have something in payment, you can leave it there or you can make it a 0 for now. We're going to come back there and solve in a minute. Future value needs to be 0. So if it's not for you, make sure it changes to 0. Then go down. Payments per year should be 12. Compoundings per year is 12. And I want you to make sure it's left on end at the bottom. Everybody got it typed in? Okay, now you go back up to payment. And we want the green solve down here. So we hit alpha, enter. If you put it in as a negative 170,000, you should get out a positive payment. If you put it in as a positive 170,000, you'll get out a negative payment, okay? The amount is the same either way. Did everybody get $861.37 if we round? Okay. 861.37, 861.37, 861.37. I'm just putting that on my home screen here because we're going to need that number in a minute. Okay. The monthly payment we got was $861.37. Now they want to know, what does that mean we really paid for our house? How would we do that, guys? We paid that every month, so we multiply by 12, and we did it for 30 years. Does that make sense to everybody? Okay, so you have to go back to the home screen, so it's second mode to quit. And then 861.37 times 12 for 30 years, or you could have just done times 360. We paid $310,093, whatever that says. 310,093 and change. Is that right? Did I remember? Okay. All right. We bought a $170,000 house. Did the bank make money on us? Certainly a lot, right? But we also got to live there for 30 years or spread the payments out, make it work. So that's why people buy houses and know they're paying a lot. Now, 4.5 is not a bad interest rate. It's pretty, might be a little high for most people right now because it's low. My first house was at 11% interest because that's what the rates were back then. All right. We are going to go down to example 2. Is this one on the sheet I gave you today, or that you picked up in the back of the room? Okay. This might apply more to your life. Okay, right now, determine the payment on a loan of $6,800 given 3.8% compounded monthly if the loan is for 5 years. So you went out and bought a used car for $6,800. That sound like something you might do? Okay, so we have N. What is N going to be for this question? I would suggest you write these down if you ever want to look back at this and remember how this worked. N was number of payments. Anybody know? Yeah, 5 times 12. Good call. 5 years, monthly payments. I is just the percent, so 3.8. Then what's next on your present value? Is that what's next going? Oh, you don't know. Anyway, it doesn't matter if we're out of order. We'll type them in correctly. Present value, you want to put it in as negative or positive? Doesn't matter. They're loaning us $6,800, so we own the bank $6,800. That brings us to payment, I think, is next on your screen, and that's where we're going to put our little cursor. Okay, future value, if it's a loan, at the end of the loan, we want it to be 0. Is that it? Then P per Y and C per Y are both going to be 12. Okay. So let's go to the calculator. How do we get there again? Apps and then just enter a couple times, right? Was it 5 years? I already forgot. 5 times 12 or 60. Someone's going to have to refresh my memory. 3.5? 3.8? $6,800? I'm just going to put it as positive this time just to show you that we all get the same answer. You can put it as negative, doesn't matter. Future value is still 0. The payment, now you could zero this out, or you could just, well, there was another number in there, hit that whole alpha enter on the payment. Anybody else get 124.62? Now, I put present value in as positive, so it gave me out a negative. Does that make sense, guys? It's always just going to have the opposite sign. Okay, 124.62. Where did I just lose that? So could we figure out the total we paid for the car? Somebody type 124.62. Did I remember the right decimal, guys? 5 payments, or 5 years at 12 payments a year. What does that come out to? 7.4. Okay. I'll just round to the dollar. We're not worried about it today. So you overpaid, but not nearly as much as you would over 30 years on a house, right? If you wanted to buy a car, the difference of $600 or $670 might seem worth it to be able to finance it for 5 years, yes? Have that car for 5 years? Okay. Example 3 says, this is more an old lady thing, okay? You're depositing $25 a month into an annuity. Might not be. Might be your parents doing this for you for college, okay? $25 a month into an annuity starting today. How much will you have saved after doing this for 40 years? Okay, I hope it's your retirement they're saving for, not your college, because if you wait 40 years, you might not remember anything. Earning 6% compounded monthly. Okay, somebody tell me something that's going in here. Uh, 40 times 12, somebody said, I think. Good job. I is 6%. Present value is 0. What are we making monthly payments of, though? Yeah, the payment is going to go in for the 25. We're starting with nothing, but we're putting in $25 a month. And we want to know how much it's going to end up with. So that's where you're going to put the cursor, is for future value. Does that kind of make sense? Okay. So we're going to go to the app And we're going to go back up here, and I already forgot. Was it 40 times 12? And the interest, 6. Present value is 0. Payment is 25. You can make it positive or negative. Make sure these still say 12 and 12 and end. So on the future value is where we do alpha enter. I got almost $50,000, yes? Okay, 49,787. Now, just because I want you to understand how this works, how much money did you actually put in there every month? $25 a month for 40 years. Can someone do that, please? I think it's like 12,000. Did I do that right? Okay. So you put $12,000 in, but you ended up with $50,000. Okay. That's because it's not just because you were getting 6% interest. It's because some of that money sat in there for a really long time compounding. Does that make sense? The sooner you start saving for retirement, the better, or for college or whatever. Okay, moving on. Sully's going to buy a $100,000 house with no money down, agrees to a 25-year loan with 4% interest. What is his monthly payment and how much do you pay in total? Anybody? Okay, I'm gonna call in some people. Tell me something. How's that? Riley, can you tell me something? Anything? What's the interest? Okay, so we're just gonna put a 4 here. Elena Finley, can you tell me anything? Good job. 25 years of monthly payments. Natalie, can you tell me something? Good job. 12 and 12 at the bottom. Easy way out. Nice job. Aiden, can you tell me something? Yep, it's a loan, so we're going to put a future value of 0, and our present value is 100,000. It can be positive or negative, and we're trying to find the payment. Okay. Go forth and conquer, guys. I already forgot what we're doing. 12 times 25 years? Okay. $527.84. Anybody get that? Again, just ignore the positive or negative. That's just one way is you getting the money, one way is the bank. Times 25 times 12. Anybody do that one yet? Did someone else get that amount? So you paid an extra $58,000 to the bank in interest. All right. I think we're almost done. Oh, I guess there's 2 more, but 6 I really like. Let's do this one though. This is an excellent thing. It says, suppose you know you can afford $300 a month for a car payment. So how much can you borrow? Would that be a good thing to maybe know how to do it the other way? So our payment is going to be $300. It says we want to borrow the money for 3 years. So that would be, N would be 3 times 12. Interest, it says, is 2.5. Present value and future value. What are we talking about here, guys? Are we saving money or are we getting a loan? It's a loan, so we want the future value to be 0. The present value is what we want to figure out. How much can we borrow? Okay. Lots of people do this when they're thinking about a house payment, right? I know I can afford this, so what kind of house should I shop for? Figure out backwards. Okay, I already forgot. Was this 36? And 2.5, and present value is what we want to find. Payment was 300. Future value is 0. So if I go back up to present value, borrow $10,000 for the car, maybe? 10,394 something. Would that be helpful to know? Okay. Last question. This is a learning moment for the day, okay? This is the difference between getting a 30-year mortgage and a 20-year mortgage on a house. And what happens? Okay? So we're going to borrow $150,000 at 7% compounded monthly. That's a really high interest rate these days, but it used to be really accurate. So the first time we do it, we're going to pretend we're borrowing it for 20 years. Okay, so do 20 times 12. And was it 7 or 7%? Okay, present value, how much about 150? Is that right? Okay, and we want to find the payment, and we're going to pay it off, so we're going to put that 0. So future value is 0, and we're finding the payment. I got 1162.95. Can we just round to 1163 just for the sake of time? Oh, that's the wrong spot. Totally wrong spot. Roughly 1163. Okay. Let's just go with the other one, and then we'll figure out the total paid because that's on the home screen anyway. Okay. Gonna go back here. If we change this to we're borrowing it for 30 years, this changes to 30 times 12. Same interest, same loan, same future value, but we just have to recalculate the payment. The payment goes down to $997.95, so $998. So what? $165 is the difference a month? Okay, $165 a month. Now let's figure out what happens long term though. So take this 1163 times 20 times 12 to figure out the total we paid if we bought it. 20 years of monthly payments at, was it 1163? I got $279.120. Anybody? Okay. If we borrowed for 30 years, it would be 30 times 12. Was it 997? 998 rounded to? 359.280. Okay. Can you subtract those two amounts, somebody? Okay. So to save $165 a month and get your loan stretched out over an extra 10 years, you paid the bank an extra $80,000. Good plan, bad plan? It's not really good financially, right? Sometimes you're in a situation where you have to stretch a loan out and make your payment as small as you can. The bottom line is you always want to pay your mortgage or your loan off as fast as you can. What did she do? Maybe drop something off? I don't know. Anyway, okay. Any questions? Okay. I think we did all the examples. There's like 6 practice problems on the back. I just thought maybe you could do a couple with a partner and make sure you're getting the same answers. This is just for fun. I thought it was like the most useful thing you were going to learn all year, okay? It's really cool to know your calculator will do this without you having to memorize any fancy formulas, right?